Hi everyone, welcome to Codebug. Today we'll solve problem number 661 image smoother, right? So first of all we'll understand what is the problem statement, then we'll move forward to solve this problem and discuss how to solve this problem and we'll go forward to the solution, right? So let me go through with the problem statement. If we simply read the problem statement, you will able to understand we need to apply a image smoother filter on each cell, right? What is the image smoother filter, right? We'll understand. That is basically the average of all the 8 cells surrounding cells and the current cell, right? That means the all 3 cross 3 matrix, and if the surrounding cell is not present, so we do not consider it into the average, right? So if you see this example, you'll also able to understand, right? This is a simple one. I'll go through the example one and then we'll solve this problem, right? So I had prepared an algorithm for that. So the problem statement is pretty clear, like, so we need to on each cell we need to calculate all its neighbors cell, including that cell also, and we need to get average of that cell, and we need to update into the resulted matrix. So first what we'll do, we'll initialize an resulted matrix to store a result, then we'll iterate over each cell in the image, right? Then we'll calculate the smoother value, that is the average of all its neighboring cell including itself. Then we'll store into our result and we'll just simply return it out. So let me go through with this example so you'll understand, right? So this is cell 0 comma 0, right? So what I'll do, okay, so if we solve for this 0 comma 0, right, its neighboring cell are this one, right? So 0 comma 1, 0 comma 0 comma 0, 0 comma 1, 1 0 and 1 1. So the total of that will be 3 and the total value are 4, and we need to calculate the floor value, so that is, we can consider the floor of that is 0, right? If we consider in the same manner for every cell, so if we consider 0 comma 1, so 0 comma 1 is this cell, right? So if we consider all its neighbor as this one, so 1 2 3 4 5, and the total number of cells, our valid cells are 6, so 5 by 6 again tends to 0, right? So in this manner if we solve for each of the cell, so the our resultant matrix will be, I'll directly update the value, right? What I'll do, I'll just copy this and I'll just paste this matrix and we'll update its value, right, directly. So that is 0 1, and for this also that is 0, right? If we consider this one, so the neighbors are this one, 3 by 4, that is 0. The sum are 3 and the neighbors are 4 including itself. And if we consider this 1 comma 0, so how many neighbors it is having? 1 2 3 4 5 and 1 itself, that is total number of elements are 6, and the sum is 1 2 3 4 and 5, 5 by 6, that is 0. If we consider for this one, so all are its neighbor, right? So 1 2 3 4 5 6 7 8 and including itself is 9. So and the sum are 8 by 9, 8 by 9 is 0. If we solve in that manner for every cell, it will be 0 for this case, right? So the our resultant matrix will be this. So what I'll do, I'll just directly solve this problem. So what we need to do, we need to just get the dimensions of image. Integer n is equals to image of 0 by size, that will consider the row and columns. Then now what we'll do, we'll just iterate over all over the image. Now what we'll do, right, we'll okay, I haven't initialized, so I'll initialize the resulted matrix also. Result we can see that is of size same m cross n. So then now what we'll do, we'll just say a result rate of I of j, it will be a filter image smoother filter, we can see on I comma j, and we'll pass m cross and dimensions also. Then we'll just simply return it out. Now we just need to apply the filter logic. So that will return an integer of, then we'll take our 2D vector, then I comma j will be the cell, and integer em comma n will be the dimensions. So just now, just simply we need to iterate all over the all over the surrounding cells, right? So if we see, so suppose we are here, right, the 7, that is, if we consider 1 comma 1, so we need to go up, down, left, right, and the 4 diagonal side. So we just simply know that we need to go from, so we'll consider L is equal to from -1 to +1. So that is from, we need to go to the left side, right, -1, and we go to the right side, that is +1. So we can consider L, we need to start L from -1. So L is less than equal to 1, L plus plus, in the same manner integer, and we'll consider k is equals to -1 for column, right. Now what we'll do, okay, let me initialize integer count. Count will be the number of elements that are present, the valid count, and the sum will be the total sum. So sum is equals to image of that I have passed I plus L comma j plus k, and its count is plus plus, and we'll just simply return the sum by count. Okay, there will be one catch. Okay, we need to calculate only if it is valid, right? So we need to put a condition over it. If we can see safe condition is safe to move into that direction, so we can just pass ri plus l comma j plus k, that cell which we are trying to visit, and the dimension of the matrix. If it is valid, so then we'll include into our result, else not. One last thing, we'll just need to write a save function. So okay, I just made a typing mistake. So then we have a raw column and integer m comma integer n, right? Then we'll just r, if r is less than 0, or r is great, it is not beyond the beyond the matrix, right? If it is going beyond the matrix, we'll just return the false, else we'll return true. Yeah, I think we are good. Okay, I just write this at, yeah, for the first sample case it is working. Well, we'll try for the next one. Okay, now it's failing, just let me check. Okay, we had just missed this. We need to get total of all the values, right? So we'll need to take a sum. Okay, what I'll do, I'll submit the code. Yeah, that's working. Okay, let me take you to the time complexity of the code, right? So if we consider the time complexity, so we are iterating over this cell, right? So we are iterating over each cell, that is m cross n, and we'll on that cell we'll applying the filter. For the filter, what we'll do, will go by all its surrounding cell. At max, there will be eight surrounding cells and the current itself, right? So that will be 9. So the time complexity will be what we can see, big of m cross n into 9, because for each cell there can be 9 cell surrounding cells, right? And we'll not consider this constant value, so we can simply drop it down to m cross n. And for space complexity, we initialize one resulted matrix to store the results, and then space complexity is m cross n also. Yeah, that's all from my side. Thank you everyone. Have a nice day.